Alright, here are the Chapter 1 PowerPoints. I'm going to go through not all of them, but some of them, just make some comments as we do so. So the first one is, thinking about what science is. All science textbooks begin with some topic like this, where we're just talking and trying to find out what science is. And of course, just generally, it's a way of thinking about and understanding, the universe around you. All right. So, of course, in chemistry and physics and astronomy and geology, we're trying to learn about the physical universe as opposed to living creatures. All right. So. Moving right along. As I said, I'm going to skip some of this. You can read this and read the chapter yourself. A big thing that we're going to do is to switch between English units like feet and pounds to metric units like units of meters. Weight in newtons, mass in kilograms, and so forth. So we'll use a lot of these standard units, and the units that we will encounter are always based on these 7 units, as you'll see as we go through the semester. Let's see. Skip this. The metric prefixes. This is a topic that we definitely want to pay attention to. In the front cover of behind the front cover of your textbook, there is a list of metric prefixes. You should definitely know the metric prefixes from pico, which means, of course, times 10 to the minus 12th. All the way to tera, which is times 10 to the positive 12. Okay, so I'll give some examples and so forth of those things. Let's see, understanding measurement. Skip these. A lot of times people think about science as just just collecting data, which is that's a good portion of what we do. But it's also analyzing the data, and let's see. Here's an equation, a relationship. So for example, you might measure the mass of an object. You might measure the volume. V stands for volume. The rho here. This is the Greek letter rho. I know it looks like a P, but it's really rho. Is called the density. So this is an equation that's often used. Anytime we have equations, it's good to know what the units are and to stick with the proper units. The mass here is usually measured in grams. The volume is measured in cubic centimeters, centimeters raised to the 3rd power. In hospital settings, for example, they use cc's, which stands for cubic centimeters. It's the same thing. So the density would be in the units of grams per cubic centimeter. Okay, so the density is usually compared to the density of liquid water, which of course is 1 gram per cubic centimeter. Okay, so things less dense than water, of course, would float in water. Things more dense would sink, and so that's why we usually compare things to the density of liquid water. All right. Let's see. All right. Let's move on. Here are some typical densities. Gold has a density, much higher than iron. There's the one for liquid water, and there's the density for air, on our planet. Let's see. Let's move on from this. Some of the stuff we'll cover in class. All right, so this is, I really want to talk about this in particular, the nature of science. So what we call modern science begins about 400 years ago, really, around the time of Galileo. Newton comes about a generation after that. So the things that Isaac Newton did was about 350 years ago. And what we want to do is contrast this with what the ancient natural philosophers, which you would nowadays call scientists, but back then, back during the time of the Greeks, when we talk about natural philosophers, the thing about them is, as we look at the scientific method, I'll mention this. They basically used the human brain and didn't. They basically thought about the human brain as this supreme entity in the universe, and was not really subject to making mistakes. Of course, what's great about the modern scientific method is that it recognizes the fact that humans can make mistakes. And because of that, because of this basic thing that humans can make mistakes, which we all know, we have this step that is built into what is called the scientific method, or the modern scientific method, where you need experimental evidence. Okay, you can't just think about an idea, and because it seems logically consistent, or because it's beautiful mathematically, that doesn't make it right. You have to have experimental evidence that will verify or prove that something is wrong, or at least partially wrong, and then that means you have to go and change things. All right. So this, of course, is the step-by-step scientific method. Science is not really done this way, not at all. It's not this formulaic thing. Okay, scientists go by hunches just like anybody, but really, when it all comes together, when a true scientific idea comes together, it has to meet all of these things. But they, like I say, you don't have to do them step by step. But this is an oversimplification of really what happens. There's a lot of inspiration. There's a lot of perspiration, so there's a lot of work that has to be done. So I'll just go through these. You observe some part of the universe. Of course, in the physical sciences, we're just looking at physical phenomena. We think about an explanation, some reason that for that observation. Gravity is causing something to fall, for example, and then we'll make a prediction based on our explanation. Okay, so this point, which is, I guess, step 3 here, this is basically where the Greeks stop. Okay, so 2,500 years ago, these 3 steps was basically what you would consider science. The thing that changes, roughly beginning 400 years ago with Galileo and others, of course, is step 4. As I said in the last slide, it allows for humans to make mistakes, because we all do. We all make mistakes. And scientists are no exception to this, of course. And so what you have to do is you have to test. You have to perform experiments. And these experiments will lead to either a modified explanation, or just entirely new ideas that we never that we never even thought of before. Okay, so this is the modern scientific method, and it's extremely useful, and has led to incredible discoveries about the nature of the universe, and of course, technologically, we've been able to engineer things, like computers and cell phones and things like that, with our knowledge of the physical universe. Okay, so it's not just something that belongs in the realm of thought. It goes much further than that. This is our modern technological society is based. You can look back about 400 years ago, and this is where the human adventure into the understanding of the physical universe begins, really in depth, in a way that we can really do something with that knowledge. Sending people to the moon, sending robots to other planets in our solar system, things like that. All right, I guess that's it for this chapter.